All right, so here we are. We're on 5.4, solving exponential equations. We've dealt with some problems like this in the past. I don't know, I believe it was chapter 8 or 9 when we solved some kind of equations, right? So it's kind of like the same process, but now we're going to go ahead and implement our exponentials. Okay, so today's notes, I'm just going to go ahead and pick through some of the problems, and then I'm going to have you do the other problems on your own, and then check with my answer key on Schoology to see what you got, okay? All right, so for number 1, it's just asking us to go ahead and rewrite with the same base. We already did that before, right? That's all this good old stuff. But now we're gonna go ahead and actually try solving for our x. So if I'm looking at part A, I'm gonna go ahead and rewrite everything with base 2. So I get 2 to the 2x is equal to 2 to the 5th power times 2 to the 1/2 power. Right, and whenever we have multiplying, right, we go ahead and add. So I have 2 to the x on my left-hand side, 2 to the 5th plus my 1/2 power. We now see that, okay, my bases are all good to go. I can go ahead and cancel those guys out and bring down what is left. So I get 2x is equal to 5 plus 1/2. And that's just going to give me 2 to the x is equal to 11 halves. Divide both sides by 2. And we get x is equal to 11 over 4. And you are done. Okay. Same thing for part B. First, go ahead and try rewriting with the same bases. Oops. All right. So I can rewrite this as, I'm going to keep the 3 and the 2x minus 1. Is equal all over 3 to the negative 3rd. Right, we see that they have the same bases, so I can go ahead and cancel those guys out, and we get 2x minus 1 is equal to a negative 3. Then go ahead and solve for x from there. So x should equal to a negative 1. Right, not too shabby. Go ahead and try doing C and D and check with my answer key on Schoology. All right, the next part is actually going ahead and using factoring techniques. So a lot of these problems, like you see already, there's parentheses around certain numbers, right? We're gonna go ahead and use GCF in this case. So we're gonna go through example A, B, E, and then you're gonna try the other ones on your own, and again, check with my answer key on Schoology. All right, for part A, we see that the 2 to the x power is going to be our GCF. So GCF is going to be 2 to the x power. You can go ahead and factor that out. So we get left with 4x squared minus 25 is equal to 0. Okay. You can go ahead and factor that guy even more. 2x minus 5, 2x plus 5. It's all equal to 0. If I were to rewrite the 2 to the x power is equal to 0, right? There is no x value that would get us to equal to 0. So this guy's actually going to be a no solution. But we can look at the 2x minus 5 and the 2x plus 5. So 2x minus 5 is equal to 0. 2x plus 5 is equal to 0. X is equal to 5 halves. Oops. 5 halves, and x is equal to a negative 5 halves. And those are our two solutions. So whenever you see something like this, where we have 2 to the x, or if it's 3 to the x, or 274 to the x power is equal to 0, there's no value that's going to get us to this 0. So it's always going to be no solution, okay? Try doing part B and C, and then meet me back at D. Okay, same exact thing. You see that the GCF is 3 to the x power. So you can go ahead and factor that guy out. We're left with a 2x squared minus 5x minus 6 is all equal to 0. This guy we know right away is going to be my no solution. We can factor out the x squared minus 5x minus 6. That's x minus 6, x plus 1 is equal to 0. And so x is equal to a positive 6, x is equal to a negative 1, and that's our two solutions. Okay, part E and F is when we're going to have to use something else, right? So if I'm looking at part E, in this case, if there is no GCF, we're going to go ahead and use U substitution, okay? So same process, I'm going to kind of rewrite this as like 2 to the x squared minus 2 to the first power 2 to the x plus 1 is equal to 0, right? Different from the other ones where each term had that GCF, this guy does not, so we are going to have to use T substitution. T substitution or U substitution, they are pretty much the same exact thing. Okay, so I'm going to go ahead and let T is equal to 2 to the x power. So I just go ahead and substitute that in. I have T squared minus 2T plus 1 is equal to 0. I can go and factor this guy out. We get T minus 1 times T minus 1 is equal to 0. And then we get a combined answer of T is equal to 1. Okay, we cannot just end there. We have to go ahead and plug back the T is equal to 2 to the x power. So I get 2 to the x power is equal to 1. And we all know that x is going to give us 0. All right, part F is the exact same process. Go ahead and try it on your own and check with my answer key on Schoology. But be careful, this one does use the natural log, which is just ln, okay? All right, next page. Number 3, it's just asking us to go ahead and change forms. So here we are going from exponential to log form. I can go and write that out. So it's from the exponential. I hate when that happens. Exponential to log form. Easy peasy, right? We take log with base 3 of 5 is equal to x. And then we are done. Part B, same exact thing. This case we are using the natural log, so I get ln of 8 is equal to x minus 1. Trying to get x by itself, so we get ln of 8 plus 1 is equal to my x. All right, part 4. This is when things get a little bit messy, but if you guys take it step by step, you should be fine. Okay, this is when we're using some of the properties that we learned from last lesson, using the product property, the quotient property, what happens when there's a power to a power, right? You go ahead and swing it to the front. So basically for these problems, right, we see that there's no logarithms or the natural log, so we actually have to go ahead and apply it, kind of like adding it in. So for part A, I'm going to go ahead and write in log on both sides of my equation, and I can rewrite it as log 4 to the x power is equal to log 3 to the power of 2x plus 1. This is when we can apply the exponent, the power to the power idea, and swing our exponents to the front. So we get x times the log of 4 is equal to the quantity of 2x plus 1 times the log of 3. Right, we see that there is a pair of parentheses, so we are going to have to go ahead and distribute these guys. So we get x log of 4 is equal to 2x times the log of 3 plus the log of 3. Right, we are trying to solve for x, so we have to go ahead and move the x terms to one side. So we have to move x terms to one side. In this case, I'm just going to go ahead and subtract the 2x log 3 on both sides. These guys cancel out, and we get x log 4 minus 2x log 3 is equal to log 3. I can't go ahead and just subtract these guys, because technically, right, it's log 4 and log 3, so it wouldn't be negative x log 4 or whatever, right? You have to go ahead and write it like this. And you're like, okay, Ms. Walter, what do I do now, right? we see that these two have the common factor of x, so I'm going to go ahead and actually factor the x out, and we're left with log 4 minus 2 log 3 is all equal to log of 3. And then final step here, just going ahead and dividing the log 4 minus 2 log 3 on both sides. So we're left with this big bad boy of log of 3 all over log of 4 minus 2 log 3. And you're done. Yay! We did it. All right, let's go ahead and tackle part B. I'm going to give you your first hint, and then I would like you to go ahead and try it on your own. Let's go ahead and use the natural log this time and put those natural logs in front, and then rewriting it as ln of 7 to the negative 4x power is equal to the natural log of 2 to the power of 1 plus 3x. And kind of go through the motions that we just did with part A. All right, if you got stuck, no worries. If you got it done, go ahead and either check your answer with my answer key on Schoology, or you could follow along right now. All right, go ahead and swing these exponents to the front. So I get negative 4x times the ln of 7 is equal to 1 plus 3x times ln of 2. Same idea as part A, you will go ahead and distribute ln of 2 on both the 1 and the 3x. So I'm going to rewrite it as negative 4x ln of 7 is equal to ln of 2 plus 3x times ln of 2. Same thing, you want to go ahead and move the x's to both sides, so I'm going to go ahead and subtract 3x ln of 2 on both sides. So we get negative 4x ln of 7 minus 3x ln of 2 is equal to ln of 2. You're going to see that, okay, on my left-hand side, we have that common factor of the x. So I'm going to go ahead and just factor it out. I get negative 4 ln of 7 minus 3 ln of 2 is equal to ln of 2. And then divide both sides by negative 4 ln 7 minus 3 ln 2. So then we get x is equal to ln of 2 on my numerator, all over negative 4 ln 7 minus 3 ln 2. And yay, you did it again. Okay. All right, so that is all I'm going to say with all of the solving of the exponential equations. For the examples that I did not do with you in this video, you will be expected to do it as on your own, right? And then check to see if your solutions match with mine on my answer key. The last part that I do want to go ahead and talk about